All right, so let's go over some squares, right? That's what I was called to do. So squares look, oh, well, let me put algebra first. This is algebra 2. All right, let's make this a little more chunkier. There we go. Algebra 2. So we're talking about squares because we're going to see this a lot, okay? So if they say square root of 25, all you have to do is whenever you think of a square root, let me color this in a different color, square root. When you see this, I want you to think of a square, like an actual square. And I want you to think of something that you, and let's say this is 25, right? So the whole square has to be 25. What I want you to say is 5 times 5 is 25, right? And guess what? That is the answer to our square root, because square roots are we're just trying to figure out the square. It's almost like saying, give me the area of a square, right? That's kind of cool. So if I said, what's the square root of, I need to go back to my primary color, 36, right? You would say, well, if I want to find the area of a square, and I know that's going to equal 36 at the end, but I got to figure out the length of the sides, what is it going to be? Well, 6 times 6, right? This side could be 6. This side can be 6, right? 6 times 6, because we're trying to find the area, is 36. So, that's our answer. 36. Oh, my bad. It's 6. Sorry. I answer 6, because that's what's going to give us 36. And this answer is 5, because that's what it's going to give us when 5 times 5 is squared. When 5 is squared, it gets into 25. So we're asking, well, what's the square root of 49? Well, if we look at a square, we say, well, it has to be a perfect square. So if this side is 7 and this side is 7, and I know that the area of a square is length times width, right? So the area equals 7 times 7. And that gives me 49. Just checked myself, so I must be right. So the square root of 49 is 7. So maybe you're like, oh, I got this, right? So what if it's not a perfect square? What if it's like some weird number? What if it's like 41, right? I don't know what that square root was going to be. Well, it's okay. There's plenty of ways to try to find it, okay? But if we can't get exact, I'll show you guys an estimation later. But just know that this is going to be very possible. Don't be like, oh, this is nothing. No, this is doable. In fact, square roots are very special. But whenever you think of square roots, think of, it's in the name, a square. All right, let's do a little bit more advanced, right? This is going to be a short lesson. I'm not really concerned about this topic. But I do want you guys to know, because it is in the future. It is in Algebra 1, Algebra 2, and Geometry. Alright, so this is kind of important. What if I said square root, but it's 3 right here, right? Let me change this in a different color. And I'll do blue. 3. Okay, so what if I wanted the square root of 3, and let's say inside here was 27. So what's going on? Well, we're saying that's not this. This is not the same as that, okay? They're totally different because there's a number right here, right? So this is basically 1, right? We just want 1 square. I'll show you guys, I don't want to confuse y'all, but we talked about there's different ways to represent different things, right? You can manipulate numbers to make them look like something, right? Well, you could do that here, but let's stay focused, okay? So 327. What's going on? Because I thought it was a square, but now that there's a 3 right there, I don't understand how I'm supposed to find a perfect square with there's a 3. But don't worry, can I just introduce to you a cube real quick, a 3D square? Okay. I think I drew it okay, right? That makes sense. 3D square, right? And a square has 6 sides. A square has 4 sides, but a cube has 6 sides. So we're only doing it in 3s, right? So this face, can I say that this face is what, 3? And can I say that this side of the face is 3? And can I say that this side of the face, because we only want 3 sides, is 3, right? Because cubes, they have 6 sides. Because if we were to look at a square with its 4 sides, and let's say we were just given the ordinary 27, right? It's kind of not possible because it's not a perfect square root. It has to be a perfect square root, kind of. So let's say it's 9. We have 4 sides, right? We have 1 side, 2 side, 3 side, 4 side. But which one are we only looking at? We only need length times width. So we could say 3 times 3. But over here we have 6 sides. So we only need length, width, and height. Or length, width, and height. Yeah, that's it. Yeah. The long side, the fat side, the tall side. So that's 3, okay? Just a reminder why there's only 3 in those 6 sides, okay? Just keep that in mind. So let's check myself. If there's 3 times 3 times 3, because we have 3 here, so 3 here, that equals 27. And if we did 3 times 3 here, because it's just a normal square root, it's 9. All right? Kind of get it, kind of, sort of. It's kind of important. Let me run down a little pattern for you real quick. I'm going to write down the cubes. That's kind of big. Cubes from 0, right, to 6. Okay. Now this is cubes. Cubes is another word for 3s. Okay. Maybe like why? Ice cubes are square. Well, we're taking into account that we have length, width, height. 3 things we need to figure out to find the volume of a cube, right? So we kind of carry that throughout everything. I think that's physics' fault. Physics, science, they kind of did this to us, but it makes sense because most mathematicians are also physics and scientists as well, okay? So we kind of collaged the mix and said, well, this makes sense, all right? So cubes. So we're talking about powers of 3. What times what equals a number. It's important to know your squares, but if you see the pattern, you don't have to memorize it. You can just see it. You're like, oh, because that's a pattern, I could see this. So if we have 0 cubes, I guess I should have wrote that down differently. Let me try again. One more time. All right, and then I'm done. I think I'm done for the day. All right, so this is 0 cubes. 0 cubed equals 0 to the 3rd, right? And remember 3 cubes, 3, put those numbers and those words together, okay? And here's the pattern. Listen up, okay? 0, that's a 0. Times 0, right? Equals what? 0. Let's do that again. What if we do 1 cubed? Right? Remember, cubed is a 3, so 1 to the 3rd. Okay? And you guys know algebra, so where you can write this out in different colors, right? You guys know what 1 to the 3rd is. So what if I kept going? 2 to the 3rd. What would that be? Do the math ahead of me, guys. Go farther than me. Finish it out. And let me be the checker, right? 2 times 2 is 4. 4 times 2 is 8. All right? What's the next one? 3/3, right? Do you see the pattern yet? No? Almost? Yeah, we're counting. So 1, 2, 3. Okay, yeah. But what's the pattern over here? What's going on over here? You guys see a pattern? I think I'm gonna run out of space before I actually finish this. Let me make this a little bit smaller. 4 times 4 times 4 equals what? 64. Okay, what's next one? 5 times 3, right? I'm gonna stop at 6. 5 times 5, because things just start getting really big, is 125. That's another pattern, but we'll talk about that another day. Last one, 6 to the 3rd, right? Or 6 cubed, right? It's important. 6 times 6 times 6. All right, let me know if you see the pattern. Give it your best shot, okay? Because there's definitely a pattern in here, and I want you to figure it out. Don't necessarily look at all this. Don't do that. But there's a nice pattern right here. Look at it, find it. Okay? Figure out the pattern. All right, so that is what a cube is, okay? So when we say find the cube root, we want 3 numbers. Number 1, number 2, number 3. This is what a cubed means. So when we do cubed root, which is also looks like this, and there's like a number inside of here, okay? Anything else I need to go over? So when people say this, right? What's And I don't know what it would be. I really don't know. Let's choose. I don't know. But if someone says this, right, we know that there's gonna be four numbers here. Four, and it's gonna be a perfect number, right? We gotta use all the same numbers. So number times the same number times the same number times the same number is gonna give us 84. Okay. I don't know what that answer is, but that's the pattern. Okay. At least that's the pattern here with all the cubes, okay? I'm not talking about this. Just talking about if we keep on going, right? You know now, right? This is a 5. Well, what are we going to do? We're going to do a number times the same number times the same number times the same number times the same number, right? We're going to do that 5 times. Good job. I think you guys got it. Is there anything else? That's all with cubes. There's nothing else really to it. I guess I will teach you later on about the difference between cubes and how to break down stuff like this, okay? We'll talk about that later, but just, here's some homework. Almost forgot. Here's some homework. I know I did all of those, but I want you to find square root. This is homework right here. Find the square root of 49. Find the square root of 56, and if you can't find it, say cannot find. All right, and put a reason why. Always gotta put a reason why. Okay, that's 1 question. That's 2 question. 3 question is 96. Or my bad, not 96. I gotta remember 26. I think that's right. Okay. So go ahead, that's your homework. Online students, put it in Google Chrome in the comment section. In-person students, take out a sheet of paper and put your name and date on it. Write your answers and go put it in my box, in the metal box, right? The metal case, whatever, it holds my grid paper. Put it in there. It's like a metal black thing, holds grid paper. You know where it is. Just put it on my desk. All right. Thank you guys so much. And if you have any questions, let me know.